scary room to be in. It's spooky.
Right now, we're wandering through what's basically an archaeological site. And what's being dug up is a lost laboratory, the last standing lab of inventor and futurist Nikola Tesla.
But I'll walk you into what is the front of his laboratory.
This lab was supposed to be the proving ground for Tesla's most ambitious idea, a wireless power and telecommunications system. He imagined the construction of a global network of towers that would electrify the world, without wires.
So this was the grandiose front door.
Okay, so clearly that didn't happen.
But this just goes on and on. It's a maze.
But the thing Tesla was chasing, ubiquitous wireless electricity, physicists and engineers are still chasing it today, and making tantalizing progress. So was Tesla onto something here? The list of Nikola Tesla's inventions and contributions is staggering. He invented induction motors and the first hydroelectric power plant. He's responsible for our use of alternating current power, and he's one of the fathers of radio communication. His patents number in the hundreds. And then there's this curiosity, the Tesla coil. It's a clever bit of machinery that functioned as a sort of tech demo. It helped Tesla show that wireless power transfer was very possible. The inner workings of this thing get complicated fast, so we're not going to go too deep. At its most basic, a Tesla coil takes in electricity with high current and transforms it into high voltage. This creates a changing magnetic field that can induce an electric field in a nearby object, say like a light bulb. So when I bring this fluorescent bulb within range, the current excites the gas and voila. An LED works differently, but the result is the same. In this case, a little electric field is generated between the prongs of the light, and it powers on as if it were plugged in. As a source of wireless power, a Tesla coil isn't really practical. One that's big enough to power, say, a room full of lights might induce a nasty current in you. It also demonstrates one of the limitations of wireless power transfer. As you move away from the power source, the strength of the field drops off very quickly. Every time you double the distance, the field drops off by a power of 6. And that's an issue of physics. There's really no getting around it. Tesla didn't fully understand his invention the way we do now. No one at the time did. But when he saw the result, it was enough to start him thinking much, much bigger. This was the stage for Tesla's ambitions, a lab on Long Island known as Warden Cliff. It's not much to look at now, but in 1901, Tesla scraped enough money together to build a massive tower. This octagon right here is where the tower once stood, almost 57 meters high. The structure showcased some of the same technology as the Tesla coil, and it was supposed to replicate the Tesla coil's party trick, too.
So he envisioned building a very large structure that could transmit power to an entire city. And you wouldn't have wired power or even metered power, you simply would have power.
Brian Field is a physicist and professor at Farmingdale State College. He gave us the full rundown of the tower's proposed functions.
He also envisioned being able to power boats at sea and be able to power things in flight. And on top of that, he wanted the same system to be able to broadcast information.
All these plans hinged on Tesla's belief that both the ground and the sky were good conductors of electricity. Basically, that electricity could be transported through them. So he imagined a network of towers, some zapping power into the ground and some pulling it back up for local use. The towers might also shoot electricity through the air like lightning, lighting up cities from the sky and powering airplanes. They'd even one-up radio transmissions of the time by sending text and images like early fax machines. He just needed more towers and money.
He had already drawn up plans to start to build another one outside of Glasgow and another one in Newfoundland as a way of transmitting data across the Atlantic.
So what would have happened if Tesla threw the lever and brought his invention online?
So Tesla was unarguably a brilliant person, but he was also very much a product of his time. And there was a few things that was missing from his scientific knowledge.
We now know that the Earth and the sky are not good conductors. In fact, they're good insulators of electricity. That means the tower itself was predicated on faulty science and doomed for failure, which, gazing back from the year 2020, seems obvious.
You have to understand that this structure was built before it was commonly accepted that there were atoms, let alone to understand how conductors worked at a molecular level. That was all a complete mystery to scientists of the time.
Brian looks back on the whole enterprise a little more charitably.
I think it's much more an example of somebody who was building on good ideas of the time and didn't know what he didn't know. And that was what was the shortcoming here.
It's been more than 100 years since Tesla's efforts at Warden Cliff. Yet, when it comes to electricity, we still live in a profoundly wired world. That universal blanket of power that Tesla envisioned still hasn't arrived. Why? Well, one reason is that our technology has changed, but the behavior of electric and magnetic fields hasn't.
In terms of power and transfer distance, I think that we're limited by physics. Now, physics can change. We don't know. But at this moment now.
Chris Mee researches wireless power at San Diego State. He says that while we're stuck with the laws of physics, upgrades in materials and other technology has led to real progress. One result is the wireless cell phone charger. The physics in play aren't so different from our Tesla Coil demo, and the transfer distance is modest, but it's practical and reasonably efficient, things that were out of reach for Tesla.
But we use the same theory. Now, why didn't he make it work? We could make it work today. The reason because he didn't have the material we have, whether it's this wire, whether it's ferrite that can use enhance the field. Secondly, he didn't have the device to generate a high frequency electrical power.
Chris and others are looking to scale the technology further to charge, say, an electric car. It could drive onto a charging pad in your garage, or even charge while you're at a rest stop in the middle of a road trip. Other techniques have allowed researchers to do safely what a Tesla coil can't: power small devices at room-scale distances using magnetic fields. Though there are still trade-offs. In this case, the entire room needs to be outfitted with a metal skeleton. For even greater distances, you need a medium other than electromagnetic fields. There's been a bunch of development around beaming energy using ultrasound, microwaves, or lasers. Chris thinks these techniques have merit, but largely for low-power applications. Efficiency is the boogeyman here, because energy is wasted in its translation from one carrier to another.
Considering the efficiency of this microwave through air with a long distance, and if you want to receive hundreds of kilowatts, you'll be needing megawatts of power at the transfer station, and you will be generating a huge amount of loss, which becomes some sort of heat.
This all adds up to something less than Tesla's wireless power vision. It's scattered niche progress, a fine-tuning of techniques, a narrowing of applications, not a rebirth of the way we use power. That's more of a Tesla thing.
I think normal people like myself, many my students, my colleagues, we're doing the work. We are sitting on the shoulders of these giants, and we're doing just a little bit incremental here and there. Tesla is different. He's the one transforming the world. That's the big difference.
So what ultimately happened at Warden Cliff and to Tesla? The tower was sold for scrap in 1917, and Tesla was forced to move on.
Tesla had some very large achievements early in life, and to make a metaphor, he always made big swings, right? And he continued to make big swings in his life. He just never quite connected the way he did when he was younger. And eventually he was, in his own lifetime, somewhat forgotten, and eventually passed away living in a New York City hotel.
But of course, Tesla's legacy looks totally different today. His work on AC power has helped define the past century. He has a unit of magnetic induction and a very flashy car company named in his honor. He's a hero among physicists and engineers around the world.
He's a hero. I don't think, other than maybe Einstein and who else has surpassed him.
And even though we still have to wire our light bulbs, he got one prediction right on the money: wireless communication. It's hard not to wonder what else he'd dream up. If he only knew what we know now.
I think he'd be happy that we do have access to text and photos instantaneously from all over the world. But what I'd really like to think about Tesla is he'd be thinking about what comes next. And that's what I'd really like to ask him about. Not what he thinks about today, but what he thinks about our tomorrow.
Hey everyone, thanks for watching. We'd like to give a special shout out to the folks at the Tesla Science Center who allowed us to visit Warden Cliff. Right now they are restoring the lab, and if you'd like updates on that project, the link can be found in the description below.